So this project is related to unlocking frequency secrets, a Matlab guide to calculating a fast Fourier transform of sine waves basically. So basically we have just calculated the FFT of sine wave algorithm which is used in signal processing. FFT is most powerful tool for analyzing the signals in frequency domains, and Matlab offers an efficient way to compute and visualize the frequency spectrum. So that's why we just talked step-by-step process of how FFT and plotting the resulting frequency spectrum, and the Matlab code how it develops its we can use the digital signal processing involves in analysis and manipulation of discrete time signals. So this one I have added the abstract with the introduction of FFT fast Fourier transform of sine wave signals using in image processing, and the waveforms we have just added. So high level programming environment basically provides an efficient and in institutive way to calculate the FFT of a signal. Basically, in Matlab, we have used the built-in toolbox called it signal processing and analysis, allowing the users to focus on interpreting results, interpreting results rather than implementing the complete algorithm in manually. So this is just an FFT example, like how the frequency is in gigahertz, and the uh, FFT of sine waves provide us the complete signal generation. Okay, so the problem statement is that we need to use the spectrum analysis of discrete time signals using the fast Fourier transform. The algorithm should be able to accurately estimate the power spectral density of a signal and identify its frequency components. So that's why we have just used in our case to analyze the objective and the problem statements. Okay, these are the constraints we have added, and design methodology, like we use the 100 hertz frequency levels. Sampling frequency is basically 1000 hertz, and the time constant as well as the yes in hertz time factor is this one, like 0 to 1 by sampling frequency, sampling rate, and then 1. Okay, 0 to 1 with the multiple steps of sampling frequency. Then the calculator of FFT using these are the equations used in our FFT calculation, plotting the results and interpreting the results. In Matlab simulation, we have used the time domain signal plot and with the frequency of 100 Hz to 1000 Hz with different amplitude levels. And the discussion of results added here, like time domain signals and frequency spectrum of the signal. Okay, the frequency spectrum is our output. This is our input, like time domain, and the frequency domain is our output levels. Frequency domain signal phase levels. Okay, here is a single-sided spectrum levels. Then conclusion and references also added in it. Okay, let me just show you these are two files used in our cases. Let me just run this Matlab code. Basically, this Matlab code is for the spectrum of sine wave time domain signals with the frequency spectrum, and second one is basically these are the parameters used for time domain signals. Yes, this one is the first one, and the time domain signal domain, frequency domain signal, and the frequency domain signal phases basically. single-sided spectrum also added in it with the different frequency levels. Frequency is in hertz, so our frequency is about 0 to 100, so that's why it provided the magnitude according to 0 to 100 levels. Okay, thank you.